I have now the pleasure to introduce you to our next speaker, talking about LCM, Fabrice Premel, SoftAtHome Senior Pre-Sales Manager.
Okay. So I'm Fabrice Premel. I work for SoftAtHome, and I will talk about lifecycle management in a purple world. Introduce you first to what it is, or remind you of what it is for those that are already aware of it. See a little bit what we do, and then do a small demo to showcase what we can do with that by basically also using some of the past presentation from Najim and from John just before, because I will be using Najim application, John OBU SPA, and USB broker, and put that all together by pushing this application and showing how it works. So let's start by a small reminder to everyone why LCM, what it is, and how to use it. We basically are seeing that the home gateways was used very first as just a connectivity application. Basically, it meant giving access to internet. Then we started to see a little bit more advanced functionalities on the gateway. And now we're going into a world where the home gateway is starting to become a platform of services, meaning lots of operators want to introduce new value-added services running in those gateways. And the more complex those applications are, the more the need to buy them from third parties. Okay? And that brings us to a change that is needed to support that. In the past, you are to bundle all those applications into a single firmware, validate it, deploy it with all its risk, and if you need to change something in one of those applications, this whole cycle had to take over again. Build everything at once, validate everything, deploy everything at once. So what was wanted is that we wanted to simplify that by allowing you to push an application, update an application, or uninstall an application independently from the main firmware in a secure manner, in a reliable manner, and with the appropriate rights. Secure, what it means that you still want to be sure that you control what's going on. Reliable, you want, of course, things to work, but also prevent this application from breaking anything. And you want to do that by giving this application only the rights that it needs. Okay? So we're going from a world of single block to a world of independent deployment units. Okay? So now we'll go into some of the details on how to do that, which protocol are used, then a small demo to show you, let's say, a real-world example. First, let me introduce you to this very, how to say it, ugly diagram that I did. Sorry about that, but at least it's simple. Basically, in the world of LCM, we need those four components. An LCM agent, it's open source inside Purple. It's integrated into the main Purple OS branch, or it's being integrated more and more with, let's say, a synchronized cycle. You need a USP agent. So in the Purple world, it's OBU SPA that John introduced just before me. You need an LCM backend that sometimes is called an orchestrator. This is something that is not provided standard by Purple because it's cloud-based, and up until now, Purple was focused on the embedded side. And then you need an OCI registry to basically host your application. OCI registry, it's something that is available in lots of open source flavors. Anything goes. OCI stands for Open Container Initiative. It's basically the most common standard format for containers. Okay? So those four blocks are needed. The two in this purple color are obviously provided by Purple, green by whoever you want, gray by whatever open source product you want to use. Open source or not, but usually for an OCI registry, you want some open source product. checking the time. So let's introduce those three constructs that we will be talking about and that are the core, let's say, vocabulary and core concept of LCM. Those three concepts were introduced in TR 157 a long time ago, I think 15 years ago now. Their basic definition is a bit broad, and in the sense of prpl, we have, let's say, tightened a bit what it means, and I will explain to you what's behind that. First, execution environment. So the official definition is a software platform that supports the dynamic loading and unloading of modules. Basically, it's a shell where you can group application inside it. Okay? In a prpl world, it's basically LCM agent providing one to many execution environments under which you will put those containerized applications. Deployment unit, official definition, an entity that can be deployed inside an execution environment, meaning it can be installed, updated, uninstalled. Basically, to keep it simple, it's a package of an application. Note that when I say basically, I already reduced a little bit the scope, and it's something that was done in prpl. We would like the deployment unit to be basically a package of an application. By the official definition, you could group many applications inside a single deployment unit. To keep things simple in prpl, usually you want to keep one deployment unit hosting an application. It's not mandatory. It's just easier if you think about it this way until you are more used to those concepts. An execution unit, what is it? Official definition, an entity deployed by a deployment unit that can be started and stopped. Basically, it's a running application. Again, in a prpl world, usually we say execution unit is one container. Whatever happens inside that container, it can host as many processes as you wish. That's a different thing. But in the prpl context, we say basically that an execution unit is one and only one container. Note that by broadband forum, those definitions are much broader than just containers. But in prpl LCM, we stick to containerized applications. For many reasons, security, isolation, sandboxing, we will see what it means a bit later in terms of functionalities. Okay? So that's another ugly diagram. This time I didn't do it, so I should not criticize it too much. But basically, here we represent what I've just talked about. Primary firmware, execution environment, and inside execution environment, different deployment units. This diagram is of interest for this presentation because not only it summarized what I just said, it also helped understand that from a security point of view, containerized applications are inside an execution environment and they are not to be allowed to get outside of that. Meaning if you apply restrictions on an execution environment, those restrictions will apply to all the execution unit and deployment unit that are inside its execution environment. Basically, we have two layers. A global layer of an execution environment, and inside, additional constraint on each EU or DU. So as I said, an execution environment has a set of available rights and a pool of resources. Each application will be able to ask for those rights or resources, but not more. Okay? Which means that from, let's say, prpl LCM point of view, we have a first layer of constraints, the EE, execution environment. And it's, from a functional point of view, very interesting to allow operators to segregate what they want to allow for applications. So for example, one use case that could be thought of, you have one execution environment for all first-party app that maybe you trust a bit more. Another execution environment for third-party app that you do not trust that much. And maybe a third for third-party app that you do not trust at all. Then that means that even if you make a mistake and grant too many rights to one of these applications, it is still constrained by the right of the EE. So that double layer means that you are also immune to one mistake that you could do when you deploy, or that a developer of an application can tell you, oh, I need those rights. Maybe you didn't see that it was a bit too much overpassing. Perfectly fine. The EE is still another protection behind that. Okay, let's talk about some of the things that you are able to use when you want to push an application or update it that will allow you to control what it can do, protect you, and only allow it to do what you want it to do and not more, not even see more. First thing, in production, it is very likely that you only want to run authorized code. Looks obvious, but it's a very important need. For that, we have signatures, okay? And let me introduce you to what I have written here, install du and update command. Those are USP commands, and you will keep hearing me talking about them because those two commands and the uninstall command are basically the three USP commands that we use and only use inside prpl LCM. There are lots of things in the data model, but most of what we do is going through these three USP commands. Of course, uninstall is more basic. So let's go back to signatures. How do we pass signatures? We pass signature URL as optional parameters of this install du and update commands. In production, then the LCM agent will download that signature, check if it matches. If so, great, this application is authorized. If not, it's rejected. Simple, efficient. You can only run authorized code on your production gateways. Second thing that is quite important is resource consumption constraints. What are we talking about here? Let's say I have an application. On the paper, it's quite lightweight, as all applications are, of course. But in practice, maybe there is a bug. And it wants to overconsume CPU resources, RAM, something like that. You don't want that to happen because if it's basically over consume RAM, at some point it could put other application or even worse, the complete home gateway into danger, meaning you could crash everything with just one application. So for that, we want to restrict the amount of resources, CPU, RAM, disk, that an application can use. Okay? We mostly leverage C group limits for that. And those limits, you have guessed it, as passed as optional parameters of the install du and update commands. Just small reminder, as always, those constraints are also inside the constraints of an execution environment. So in my previous example, if you install this third-party application into that very entrusted execution environment, which has, for example, 2 megabytes RAM limits, okay? The application inside that EE will have their own constraint and the constraint of the top EE, okay? As always, double layer. Next thing, very important, and it's also related to the John presentation. USP roles. Basically, you can grant USP roles to an application. The main use case, not the only one, but the main use case is that this application, since it has those USP roles associated, will only be able to see and interact with specific parts of the data model if it's interacting with it over USP. We've seen in the previous presentation, basically, if it's open bar, you can query anything, including sensible information that has nothing to do with your application. With USP role, you can constrain what that application can see or write to in the data model. Okay? Very important because, as you know, the data model is a key element and you can do anything, including bad things with it. just forgot to mention for USB roles, as always, those are optional parameters of those two USB command install DU update, as always. Next thing is network access. It's nice to have applications, that's great. You do not want to give all rights to those applications in terms of network access. Some of them, you might not want to give them any network access. Some of them maybe just LAN access. They are not allowed to go to the internet. Some of them, anything. You can even want to have some of those applications act as servers and be reachable over the LAN or over the WAN maybe. Okay? For that, we have the network config parameter. You can apply to an application specific rights. For example, it has one access, and it will be allowed to bind to port AT&T, and all incoming flows will be redirected to that port AT&T. Okay? Very important, because you most likely do not want to have all applications being able to do whatever they want on the network, including binding to ports. We do that mostly through namespaces and firewall rules. One parameter that I didn't mention that could be of interest for some of those applications, especially security applications. By default, we use separate namespaces. We have a parameter so that an application that is very trusted and very critical could share the host namespace. Okay? And you guessed it, network config parameters is an optional parameter of the install DU and update commands. Another thing very important, you can share a file, and file being a Unix file, so an actual file, a directory, or a socket, between the host and a container. This is done through the host object parameter or optional parameter of the install DU and update command. I think you have understood how it works. This is actually a very useful feature, especially related to the previous presentation that John did. For example, one of the things that you want to share between the host and the container is the socket onto which the container can connect, for example, to the USB broker. Okay? Then, with this container can access the host data model or even provide an addition to the host data model thanks to USB services. So this is very valuable in real life. Next, application volumes. Of course, your application might not want to store anything. Most applications will actually want to store something. You want to basically allow application volumes to be attached to a container, and each volume will have its specific characteristic. Maybe it's to be persistent. Persistent in this sense means if you uninstall the application, we'll keep the data. And if 6 months later you install it back, you have access to this data. Encryption, capacity, of course you want to restrict the volume that will be attached to the container. And I told you that I will be repeating myself, though this is an optional parameter of the install DU and update command. Small overview on the protocol that we use for prpl LCM. Okay? Of course, it's USB based. It's using the USB version of the TR-181 data model. It's a choice that was made at the beginning of prpl LCM. It's to go USB only. It's a question that arises quite often into the prpl LCM working group. What about TR69? The TR69 version of all that I have presented before, TR-181 data model extension and new things that have been standardized in Broadband Forum, is not available in the TR69 version. It's only in the USB version of TR-181. That does not mean that you have to migrate all your gateway over USB. You can use USB just for LCM and stick with TR69 for everything else. It's a very frequent question. That's why I'm insisting on that. In prpl, LCM is over USB and USB only. So another protocol that we quite often use is MTP, UDS. Very convenient. You do not have to use it. It's not mandatory, but it's very convenient because everything is made to work with it. We've talked about it. USB roles, capability to share that socket that application can connect to the host data model. So it's very convenient. And if possible, my opinion is that most applications should use that if they want to communicate with the host. It's not mandatory. Same thing for USB services. It means that an application can basically extend the data model. Again, not mandatory. Very convenient, very prpl-like, very recommended. Next things, I've talked it in one of the first slides, OCI repositories. We use OCI and OCI only as the format for those deployment units. Open Container Initiative, basically, it's Docker a few years ago who gave their format to the Open Container Initiative to make it as standard and as open as possible. So experts will scream when I say that, but for all practical manner, you can confuse it with Docker images. Okay? Of course, we could study other protocols. Some operators would like also to use something else, but as standard, prpl, LCM, we use that. That's a real-life example, just to show you quickly, and because it's something that we also show in the demo. Basically, this is an example of an LCM backend or LCM orchestrator. In this case, it's SoftAtHome 1, but anyone can go. All protocols, all interfaces are open and standard. This is prpl that we're talking about. And for example, in this screenshot, you can see that when you declare an application, you can configure all the parameters that we've seen before. Okay? So let me reconnect so that because I will have also a demo to do. And I'm checking the time. Yes? Yes, I'll connect again and I'll plug the HDMI. Yes, thank you. So I'm sorry, I need a few seconds and I should be good. So in this demo, when I'm reconnecting because my stupid computer went into power saving mode, I will just introduce what I will do. What I will do is that I will show you how we will be pushing an application with specific rights on a stock prpl release, see how we can look at the data model part, at the software modules part of the data model to see how you can look at what is being installed. And then once it's done, with the application that Najim built a bit earlier today, I will show you how it has extended the data model and how you can query it from outside the container. And basically how you have enhanced the stock prpl OS on the fly, securely and remotely. So give me a few seconds and I will finally plug the HDMI cable. Right now I do not want you to see all the stupid things that I type. Okay. Okay, so I'm connected to stock prpl, max linear, very easy. And let me show you first how it's going at the data model part. So as always, we are looking at software modules, subtree of the data model. Right now, you can see I have one execution environment that has been created, no deployment unit, no execution unit. So basically, it's all free. Of course, if I query this data model with the phone book part that the application from Najim is supposed to export. Of course, it's not available, it's not yet installed. Okay. So now, let's install it. So, I am probably, let me check if I have not timed out. Wow, wonderful. So this is the application that Nabil built earlier today. Najim, sorry, built earlier today. This application is hosted on an OCI registry. I have already pre-declared it in this LCM backend. Of course, we do not have time to do everything by hand. What I want to show you here is that it has multiple versions, of course, declared. And I will show you for the version that I will use. Here, I have declared two host objects. Okay? Sorry, it's on the screen. One is, of course, the file that OBUSP is using to connect to, the OSP-USP broker. And the second is basically the logs. Okay? Those two host objects will be passed to the gateway when I will deploy the container. Okay? So let me do just that. Oh, before I publish it, actually I will put a listener here so that you can see it live. I publish the release that I've just shown you. We'll wait a couple seconds and it should arrive on the gateway. Things look like they are working, so that's great. I will show you what it means in the data model, basically, just to remind everyone of what happened here. The LCM backend, or LCM orchestrator, talked over USP to the gateway with the install du USP command, with the URL of the OCI file, with the host object parameter, and since it's a trusted USP controller for the software module part of the data model, it has installed, the LCM agent, sorry, has installed it. If I look back now at how it looks at the data model part, you can see I have a deployment unit here with the phone book application. It's being running inside an execution unit. You can see also the two host objects that I have declared on the backend. So I have to look at the right screen. Okay, you can see it there. Okay. And now, from the host, if I query the data model, I can see that everything that Najim application exports is available and can be queried. Here I'm querying it from the host. It could be queried also from another application. That's very important. That means that application can also be building blocks for other applications. Okay? This extension of data model is basically USP services, and it's basically what I just did here in 2 minutes is the conclusion of what Najim did this morning and what John just presented before. Okay, it's the final step. Okay? So I think I have a couple minutes left. We can go through a small question and answer if you have any. And I can also present you one very important feature that we will introduce this year as part of the 2024 Purple roadmap. I will start by, yes, you have a question? Okay. I will start maybe by introducing something that we have in the roadmap, and then we'll go for a quick question and answer if we have time. Something that I have not talked about is what type of container are we talking about. So it's LXC container, and by saying that, I didn't say the word that is the most critical, privileged or unprivileged container. Okay? Right now, up until this year, and it will arrive this year, we were dealing for Purple LCM and the LCM agent with privileged containers. And the big thing that we introduced this year is full support for unprivileged container. And full support, I want to make it clear what I mean by this. Full support not only means, of course, running unprivileged container, that's the easy part, but for example, we've talked about host object. Okay? If you want to share a file, the user under which the unprivileged container is running must have access to that file. It's a new problematic. You didn't have that with privileged container because everything was root. It's easy when it's root. So this introduction of full support of unprivileged container is quite some work, and it's something that we believe is very important from a security point of view. But actually, let's say, impacts with everything that I have presented so far. That's why it will be introduced in lots, let's say, multiple lots this year, but by the end of the year, we should have everything fully supported for unprivileged container, which we believe is a major need for most operators. So I think I have like 3 minutes, if I'm not mistaken. So are there any questions, please? Yes? No? Yes, please.
So is there going to be some question about whether a container should be root versus not root?
Yeah, I'm sorry.
Is it working? Yes. Yeah. So is there going to be some direction about which container should be root versus which container is non-root?
I would say the general guideline would be that as much as possible, everything should be unprivileged container. At the end, the operator is the master of its gateways. If you want to run anything under root, it can. But it would not be good practice to have containers running under root, meaning privileged container, in the future. I'm not here to mandate anything, but the general advice would be try to run everything unprivileged container as much as possible. You probably, except for a few exceptions, do not need root privileges.
So then who defines all the APIs that the application is going to require, right, to operate as non-root? Because everything is not available in the data model, right? You cannot define every single thing that this application is supposed to do, right?
No, that's a good question. The dream is that you will have at some point high-level API for everything. The reality is that you do not have them right now, you're right. So basically, for everything that is not available as a high-level API, you will have to poke a hole into that isolation, into that sandboxing, so that your application can still do whatever it needs to do. Most of those holes, but not all, would be, for example, sharing a file, a device file, or something like that. Most likely, you do not need root for that, as long as your container and the user underneath it's running has the appropriate rights to access that file. This is what we will introduce this year. It should, high-level API plus those host objects, support most needs. But you're right, and I've said it, some specific application, I'm thinking, for example, security application might need much more. And for that, the capability to run privileged container will be kept. Okay? We will not drop privileged container support. But it should be used as little as possible and only when there is absolutely no other way of doing things.
So there's also the time sensitivity, right? There are certain applications that need to configure certain low-level APIs or low-level hardware within a certain period of time for those applications to make sense, right? So if I'm running an unprivileged and then I need to go and inform the host operating system that go and configure the IP tables, there might be a little bit of lag between when the application detects something and then the time when the operating system is able to configure that on the low levels, right? So how do we address that?
I do not think that there is a standard mechanism to do so. I'm turning also to Wouter. As far as LCM is concerned, I do not think we have that right now, and I'm not sure it's something that we have already a standard way of dealing with. Yes. So I'm just repeating what Wouter said. You should connect to the prpl LCM working group to bring this question so that we can take that into account. Yes.
Okay, thank you.
Sure. Yes. There will. Yeah.
I saw the domotic container on the web UI that you have presented, and this leads to me to a question. Is there centralized app store for all vendors, or every vendor should provide their own implementation of the containers? Because as I saw, inside the container, we need to provide some sort of API to speak with the USP agent and retrieve the data. So, yeah, my question is there centralized app store?
Yes. So right now, there is nothing as a centralized app store in prpl. There were people discussing it, saying at some point it could be a good idea. I'm not here to answer that question. I can only say that right now it does not exist. And to me, and I'm just sharing my opinion here, something that I have not talked about, and that was, I think, mentioned earlier this morning, is that for your application to work, yes, they need to have those API, but it also needs some kind of certification. Okay? If you have a custom version of prpl, maybe your application will not work with it. So at some point in the future, as part of the certification process, a set of version of API needs also to be certified. So, and to me, that's related to a centralized app store in the sense that you want to guarantee that an application, if it's stamped as being certified, can run on all certified prpl OS flavor. Right now, this is not available, but it's a huge topic, and I think everyone is aware that at some point we need to provide answers to that. Yes. You want to add something over there also?
Maybe just following up on that. So these are applications that are deployed by operators. So it's generally from their own infrastructure, from the remote management that they will be hosted and not in centralized app stores. But indeed, for use of certification and for prpl reference platforms, it would be great if we would have a centralized app store. We've already asked some vendors to see if that is something that they would be willing to contribute. At the moment, I don't think we have an answer to that yet.
Do we have time for other questions? Okay. So thank you very much, everyone, and have a good day.